It is not legal to mount a fluorescent light fixture directly to wood without using a heat-resistant barrier. The National Electrical Code (NEC) requires that electrical fixtures must be installed in a manner that minimizes the risk of fire. Exposed wood is a combustible material and can ignite if exposed to excessive heat from the light fixture. The NEC requires that fixtures mounted on combustible surfaces must have a heat-resistant barrier between the fixture and the surface. The barrier must be made of a material that can withstand the heat generated by the fixture. There are several types of appropriate barriers available. Firstly, fixture spacers. These are metal or ceramic spacers that are installed between the fixture and the wood. Secondly, mounting plates. Metal or fire-resistant plastic plates can be installed between the fixture and the wood. Thirdly, heat shields. Reflective shields are available to protect the wood from the heat generated by the fixture. Installing a fluorescent light fixture directly on wood without a heat-resistant barrier is a fire hazard and can result in fires, property damage, and injuries. It is recommended that you install the fluorescent light fixture with the appropriate heat-resistant barrier to ensure fire safety. It is also recommended to contact a qualified electrician for proper installation. The NEC is a set of standards published by the National Fire Protection Association (NFPA) to provide guidance for the safe installation of electrical wiring and equipment. It is updated every 3 years, and local jurisdictions often adopt it into law. Following the NEC helps ensure electrical installations are safe and reliable. When dealing with electrical installations, it's crucial to understand the concept of ampacity, which refers to the current carrying capacity of a conductor. The ampacity of a wire is determined by several factors, including its size, material, insulation type, and the ambient temperature. The NEC provides tables, such as Table 310.15, that specify the ampacity of various conductors under different conditions. It's essential to select conductors with adequate ampacity for the intended load to prevent overheating and potential fire hazards. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices are rated in amps and are designed to trip or blow when a current exceeds their rating. The NEC provides guidelines for selecting the appropriate overcurrent protection for different types of circuits and equipment. Proper overcurrent protection is essential to prevent damage to equipment and reduce the risk of fire. Grounding is a critical safety measure in electrical systems. It provides a low impedance path for fault current to flow back to the source, allowing the overcurrent protection device to trip and energize the circuit. The NEC specifies the requirements for grounding different types of electrical systems and equipment. Proper grounding helps to prevent electric shock and reduce the risk of fire. Electrical enclosures are designed to protect electrical components and prevent accidental contact with live parts. They are available in various types, each designed for specific environmental conditions. The NEC specifies the requirements for selecting and installing electrical enclosures. Proper enclosures help to ensure the safety and reliability of electrical systems. Wiring methods refer to the techniques and materials used to install electrical wiring. The NEC specifies the permissible wiring methods for different types of installations. Common wiring methods include conduit, cable, and surface raceway. Selecting the appropriate wiring method is essential for ensuring the safety and durability of electrical installations. When working with electrical systems, it's crucial to follow safe work practices. Always de-energize circuits before working on them and use appropriate personal protective equipment, PPE, such as gloves and safety glasses. The NEC provides guidance on safe work practices for electrical workers. Following safe work practices helps to prevent electrical shock and other injuries. It is also important to understand voltage drop in electrical circuits. Voltage drop is the decrease in voltage that occurs along the length of a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or overheat. The NEC provides guidelines for calculating voltage drop and selecting conductors that minimize voltage drop. Understanding and mitigating voltage drop is essential for ensuring the proper operation of electrical equipment. Also, consider arc flash hazards when working with electrical equipment. Arc flash is a dangerous phenomenon that can occur when a short circuit creates a high-energy electrical explosion. Arc flash can cause severe burns, injuries, and even death. The NEC requires employers to assess arc flash hazards and implement appropriate safety measures to protect workers. These measures may include wearing arc-rated clothing and using specialized tools and equipment. In addition to the NEC, other codes and standards may apply to electrical installations. These may include local building codes, fire codes, and industry standards. It's essential to be aware of all applicable codes and standards and to comply with them. Compliance with codes and standards helps to ensure the safety and reliability of electrical installations. Regarding specific types of lighting, LED lighting is becoming increasingly popular due to its energy efficiency and long lifespan. LED fixtures are available in a wide variety of styles and sizes, making them suitable for many applications. When installing LED lighting, it's essential to follow the manufacturer's instructions and to comply with all applicable codes and standards. Be sure that the LED driver is compatible with the supply voltage, such as 120 volts or 277 volts, and that the wiring is properly sized and protected. For commercial buildings, lighting control systems can help to save energy and reduce operating costs. Lighting control systems can be programmed to automatically turn lights on and off based on occupancy, time of day, or daylight levels. The NEC provides guidelines for installing and wiring lighting control systems. Proper installation and programming of lighting control systems can result in significant energy savings. Emergency lighting is essential for ensuring the safety of occupants in the event of a power outage or other emergency. Emergency lighting systems typically consist of battery-powered lights that automatically turn on when the normal power supply fails. The NEC specifies the requirements for emergency lighting systems, including the number and location of lights, the duration of illumination, and the testing and maintenance procedures. Ensuring that emergency lighting systems are properly installed and maintained is crucial for the safety of building occupants. When working with electrical equipment, it's essential to use the right tools for the job. Use insulated tools to prevent electric shock and make sure that your tools are in good working condition. Inspect your tools regularly for damage and replace them if necessary. Using the right tools helps to ensure the safety and quality of your work. Additionally, proper labeling of electrical panels and circuits is essential for safety and maintenance. Label each circuit breaker or fuse with the description of the load it serves. This will help to prevent accidental disconnection of critical circuits and make it easier to troubleshoot electrical problems. The NEC provides guidelines for labeling electrical panels and circuits. Make sure that your labeling is clear, accurate, and up to date. When installing wiring in walls or ceilings, it's essential to protect the wiring from damage. Use conduit or cable protectors to protect wiring from nails, screws, or other sharp objects. The NEC specifies the requirements for protecting wiring in walls and ceilings. Proper protection of wiring helps to prevent short circuits and other electrical hazards. Also, be aware of the requirements for electrical clearance around electrical equipment. The NEC specifies the minimum clearances that must be maintained around electrical panels, transformers, and other equipment. These clearances are necessary to provide safe access for maintenance and to prevent accidental contact of live parts. Make sure that you maintain the required clearances around electrical equipment. Surge protection is important for protecting sensitive electronic equipment from voltage surges. Voltage surges can be caused by lightning strikes, power grid switching, or other events. Surge protectors are designed to divert excess voltage away from electronic equipment, preventing damage. The NEC provides guidelines for installing surge protection devices. Consider installing surge protection for your sensitive electronic equipment. When working with high voltage equipment, it's essential to take extra precautions. High voltage can be deadly, so it's crucial to follow all safety procedures. Wear appropriate personal protective equipment and make sure that you are properly trained before working on high voltage equipment. The NEC provides guidance on safe work practices for high-voltage electrical systems. Regarding electrical inspections, many jurisdictions require electrical inspections to ensure that electrical installations comply with the NEC and other applicable codes. Electrical inspections are typically performed by qualified electrical inspectors. If you are installing new electrical wiring or equipment, be sure to obtain the necessary permits and schedule an electrical inspection. Passing an electrical inspection helps to ensure the safety and legality of your electrical installation. Ground fault circuit interrupters, GFCIs, are life-saving devices that protect people from electric shock. GFCIs are designed to trip quickly when they detect a ground fault, interrupting the flow of electricity and preventing a potentially fatal shock. The NEC requires GFCIs in certain locations, such as bathrooms, kitchens, and outdoor areas. Make sure that you install GFCIs in all required locations. It's also important to understand the difference between arc fault circuit interrupters FCIs and GFCIs. While GFCIs protect people from electric shock, FCIs protect against electrical fires. FCIs are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. The NEC requires FCIs in certain locations, such as bedrooms and living rooms. Make sure that you install FCIs in all required locations. For outdoor electrical installations, it's important to use weatherproof equipment. Weatherproof equipment is designed to withstand the effects of rain, snow, and other weather conditions. The NEC specifies the requirements for weatherproof electrical equipment. Use weatherproof equipment for all outdoor electrical installations. Regarding underground wiring, it's essential to bury the wiring at the proper depth. The NEC specifies the minimum burial depths for different types of underground wiring. Burying the wiring at the proper depth helps to protect it from damage and prevent electrical hazards. When working with electrical plans and blueprints, it's important to be able to read and interpret them accurately. Electrical plans and blueprints show the layout of electrical wiring, equipment, and components. Understanding electrical plans and blueprints is essential for installing electrical systems correctly. Also, be aware of the requirements for accessibility of electrical equipment. The NEC specifies the requirements for providing access to electrical panels, disconnect switches, and other equipment. Providing adequate access to electrical equipment is necessary for maintenance and repairs. When installing electrical equipment in hazardous locations, such as areas with flammable gases or dust, it's essential to use explosion-proof equipment. Explosion-proof equipment is designed to contain any sparks or explosions that may occur inside the equipment, preventing them from igniting the surrounding atmosphere. The NEC specifies the requirements for electrical equipment in hazardous locations. For electrical maintenance, it's important to perform regular inspections and testing of electrical equipment. This can help to identify potential problems before they become serious. Regular maintenance can extend the life of electrical equipment and prevent costly repairs. Regarding troubleshooting electrical problems, it's important to have a systematic approach. Start by identifying the symptoms of the problem, and then use a multimeter or other testing equipment to narrow down the cause. Always follow safe work practices when troubleshooting electrical problems. And finally, consider energy efficiency when designing electrical systems. Use energy-efficient lighting, appliances, and equipment. This can save money on energy bills and reduce your environmental impact. The NEC provides guidance on energy-efficient electrical design.